Hello dears, welcome back to a new video. In today's video, we are going to see CST. What is CST? That is critical solution temperature. Okay, so in last class I already said we discussed about partially miscible liquids, right? What was partially miscible liquids? Yeah, it will get completely miscible in above or below some temperature. Okay, so that temperature we are calling as a critical solution temperature. Actually, what was partially miscible liquids? The liquids which is not miscible in some proportions, but it will get miscible in some extent. Here the solubility is depends upon the temperature, right? So you will see what is solubility of in solubility. What is CST? Yeah. So CST is the temperature at which two partially miscible liquids become completely miscible in all proportions, forming a single homogeneous phase. So what is CST? The temperature at which two partially miscible liquids become completely miscible in all proportions and it will form a single layer. So below or above this temperature, the liquid exists as two separate layers. Okay, so based on the temperature above or below criteria, it's classified into three types. One is upper critical solution temperature, upper CST. Okay, so upper CST means the maximum temperature above which two partially miscible liquids become completely miscible. So here, if you increase the temperature, the intermolecular interaction between the liquids, it will reduce, it will weaken, thereby it will get miscible. That's what the maximum temperature above which two partially miscible liquids become completely miscible. So we can give the example of phenol and water. So it shows the upper critical solution temperature near about 66 degree Celsius range. Okay, so below this temperature, below this 66 degrees Celsius, your phenol water system will show the two separate layers. Okay, so comes to the lower CST. Lower CST means the minimum temperature below which two liquids are completely miscible. So example is triethanolamine and water. The lower CST of triethanolamine and water is near about 18 degree Celsius. What is lower CST? This is the minimum temperature below which two liquids are immiscible. So we can remember, if it shows the above temperature, above this temperature, it will show the two separate layers. Okay, so next comes to the special case. Special case means the liquids which will show the both upper CST as well as lower CST. So we can give the example of nicotine and water. This CST will come for 5-mark question. Okay, so how they will ask? You have to define the CST, what is CST, and you have to classify it, and you have to give the applications of CST. Okay, that will give you the 5 marks. And here the temperature is important, plus what is the example. Upper CST, you will remember the example of phenol water system, and the upper CST is 66 degrees Celsius. And in the lower CST, you will remember the triethanolamine and water system, it will show the 18 degrees Celsius LCST. Okay. Then special case in that you will remember nicotine and water. Next comes to the applications of CST. So here, selection of the solvent system. The first application is the selection of the solvent system. That means when we are designing a formulation, that means it is helping in the formulation design. So suitable solvent combination for liquid dosage form we can select by using the critical solution temperature. Next one, liquid extraction. Helps in temperature control to obtain single or two phases as it required. Next comes for the purification of drugs. So it will allow the easy separation of impurities based on the CST. Next, emulsion formulation. We know emulsions are thermodynamically unstable because it's a It is the phase which is containing the two immiscible liquids. So base, if we know the miscibility region, so it will help in the emulsion stability. Next comes for the study of molecular interaction. So the CST allows to the strength of solute solvent interaction. We can study the strength of solute solvent interaction from CST. The last application is the quality control. So the CST will allow us to study the purity parameter. Okay, these are the application of your CST. Majorly in the formulation design and the separation techniques, okay, extraction. So these are the application of your CST. Okay, so hope you people understood my class. So stay tuned for my next video. So thank you for watching. Bye bye.